Hello, I'm Nathan. I go by Myobi a lot of times, almost everywhere. I have a lot of slides, so they're going to go about this speed, but everything good is at the end, so don't worry about it. There'll be Q&A at the end, so I'm actually going to try to get done a little early because I want to hear your questions, because I have idea and I want to convey the idea, and then you can tell me how bad it is. I do this for a living. I design distributed systems. I didn't used to, but I accidentally have a career and it's spiraling out of control, so that's what I do. And I made my own presentation software, which is a really bad idea, and you should never do it unless you really want to be stressed out right before you talk. I use this for JavaScript. I just like it, so I wanted to tell you. It's a great JavaScript framework. It's like 5 kilobytes. This is what my side looks like. Again, I'm just telling you how stressed out I am. There's no speaker notes because I couldn't get that feature finished. You know, yeah, don't do your own, yeah. This talk is actually interactive. The Wi-Fi has been working fine. I added this slide in case the Wi-Fi didn't work fine, but I think the Wi-Fi is fine. There's a website you can go to, and you can actually do some things. And it will affect, well, we'll see actually. It'll affect the screen. You can actually rate how you feel. That line is actually the current average rating of me. I moved it a little bit, you see? So if you start rating up and down, the line might update. I don't know. We'll find out. There's a Phoenix server running somewhere, hopefully. Who knows? You can also submit an emoji, and they should appear in a corner. They do at most 1 every 10 seconds. And I have good validation. You can only send 1 emoji. I found a good regex that matches all the Unicode code points. Doesn't matter. So have a good time with that, hopefully. Yep, it's great. Phoenix is pretty good at WebSockets. So distributed applications are hard. This is basically the beginning of my story to get to the idea that then you can ask questions about. This is why it's hard, because everything's terrible. Networks are terrible with like EC2, right? I get EC2 instances that just don't have network, you know. Concurrency's hard, although we do have like Elixir and Erlang, but like concurrency in a system, I mean, you have 2 computers, so like, you know, managing concurrency on 1 computer is easier than 2. Locking is basically most people don't even try. They just let their database linearize their whole system. Like if you use Postgres, you're probably just using transactions, and then you're like, hey, I don't have to do that anymore. And then stale data. A lot of people don't realize, but they probably have problems with stale data. This is how I feel about it. I found this awesome painting, and that's how I feel about distributed systems. It's very fun, but I'm dead. Yeah, so I want to bring this topic up again. This is not what my talk's about, but I just feel like, I don't know, I like talking about this. You probably have stale reads in your system, depending on how you've implemented it. You're probably like, I use Postgres, it's consistent. Yeah, but you know, TCP is problematic, and you can do a get, and then before your get returns, if someone else does a post, or even if you do a post, because you're probably in a request pool, you might get the get later. It may have returned it before the post, but you may not receive it until after. And this actually, I used to work on Wunderlist, and if you've ever seen a task disappear, that's why. Because we could download the array of tasks, and if it's not in the array, it just goes away. It literally happens all the time. You'd be very surprised how often networks are terrible, and now we have lots of emojis. Cool. Scaling is also hard, right? We're getting somewhere, I promise. And this is why. Load balancing is great, right, until it's not. Parallelism is great until it's not. And databases are just like, I mean, do you know how often your auto vacuum's running? Because if you don't, you're going to find out. Like, you're going to have a bad day, probably a bad few days, honestly. Like, yeah, I've been awake for like 48 hours at a time trying to fix auto vacuum running on RDS. And you still have to vacuum. Like, I know some people is like, you know, it's auto vacuum. They're like different. They don't do the same thing. It's terrible. That's how I feel about it. So then you're like, well, then why am I even going to do this? Like, I just have 1 computer, and that's fine. It is fine, actually, but this is probably why. You probably want to do some scaling. You probably want to have, in quotes, billions of users, right? You probably have like 100,000, and that's great, actually. I like systems that have like 1,000 users, because then it's like, you don't optimize anything. You know, it's great. You just ship all the time, and like, it's like these 1,000 people have no idea it's slow. You probably want your app to work offline, and networks are bad. Like the network here is bad, and cellular networks are bad, although they're better than like coffee shops and hotels now. So that's how I feel about that. I watched a talk by Joe Armstrong recently. That's a name drop. See, I don't know him. I just watched the talk. Like, this is the URL that you'll never be able to remember. But he was talking about this great analogy, which is if you had a container and you tried to fill it with bowling balls, right, you would have all this empty space. And he's kind of talking about the computer and like the compute capacity of it. And so if you write these monolithic algorithms or monolithic applications, it becomes harder to scale on one computer, it becomes harder to scale across many computers. Instead, if you pour sand into a container, you don't have any wasted space. And so this is what it meant to me, is that the more granular you are, the more scalable you are. Yeah, so we're getting, I promise this is all gonna. So we had a crazy idea. A few of my friends may have been talking about it forever, and so I submitted a talk about it, and then it got accepted, and then I had to make a library to do it. So having a central database, like I said, makes some things easier. You can linearize, you can use transactions, it's fantastic, but it's hard to scale. We're on Wunderlist is on the biggest Amazon RDS, and if they come out with a bigger one, we'll do it, please. So it's pretty annoying. So this is what we think. What if everybody had their own database, right? And what if it was just a file? Wouldn't that be great? That'd be so easy. Yeah, I found this awesome picture. He's like, whoa. Okay. So the reason most people don't do stuff like that is because time, which is interesting because Jose mentioned it this morning. Time in a system is just impossible to understand because human time cannot be trusted, right? We all know this, well, hopefully. And if you don't, you learn it the hard way, like I did, when they're like, hey, design the sync of an app. And you're like, oh, it's easy, I'll do that, yeah. This is just a cool picture. This guy does this generative art. I just search for words to find pictures for my presentation, and when I search for time. But this is actually, he built this plotter, and it has a pen, and it so it generates the art in memory, and then the pen plots it. That has nothing to do with anything. It's really cool. His name's Anders Hoff, and he has a Twitter account there, and he posts his new generative algorithm. He posts the code too. He writes it in Clojure, Python, and stuff like that. Yeah, so I believe that all working distributed systems are just an implementation of how that organization understands time. And I think when you look at any kind of sync algorithm or whatever, that's basically what it is. Let's talk about some more concepts because we don't need to go anywhere. Actors are great. This is what I thought Erlang was about until I learned about processes, right, which is just an actor with a funny name that's then you have to always say not OS processes. And yeah. This is this photographer guy, and he takes pictures of his daughter acting in different scenes. So this is what I found with the word actor. And I also just think it's hilarious, the samurai sword and stuff. So at Wunderlist, we actually use actors to wrap each WebSocket connection. We use Scala and Akka, and that's been great. It's a great way to contain state, linearize access to things, make sure everything happens in order, and oh my goodness, that sounds very interesting, right? So Elixir has processes. So then we thought, well, what if every user had their own process in the system, right? And then we get all the benefits of, that. But the problem is, how can we know that that one process is that one user? You know what I mean? We really need to know. There can't be two. If there's two myobis, right, in the system, and we're load balancing because that was already on the slides, which one am I talking to? I don't know. So of course, you're just going to use global, right? Yeah. Well, it turns out global's not consistent all the time, and you're probably thinking are you sure about that? Because it's called global. Yeah, but if you look at the docs, there's three interesting parts of this sentence in the docs. The first thing that jumps out to me is name clashes. How is that possible? And then discovered. So it's name clashes at some other time. And then there is a function called resolve that you can implement, and you would not have that function if you didn't have conflicts. So that's how I feel about that. So then you're man, there's other things. I promise, there's other things. Yeah, but that's not consistent. And you're are you sure? And it's great because I love this. It replicates all lookup information in a way that doesn't require consistency, which is great. It's very fast. But it's literally the opposite of being consistent. So that's great. And there are a lot of applications that is the best. If you're doing IoT stuff and it doesn't really matter if you can identify this one light bulb literally 100% of the time. Who cares, right? And you're probably thinking JPROC, I don't know, man. I don't know. Yeah. I like this. It's I found this on a web page, and it's it just says gen leader is problematic. And I'm what does that mean? I don't know. I've never used it. I just see stuff. I've never read a good article about Gen Leader. Have you? Like I've read bad articles and I've never read a good one. I want to use it because I'm like, what could it have done to these people? But like, that's how I feel about that. And then you're like, I have seen on Hexdocs, Elixir has a registry for processes. And that is true. It runs on one VM and it's consistent because it's on one VM because in quotes, that's easy, right? And so you're like, we're gonna be clever. We're just gonna run one computer that's the registry, right? The problem is if that VM stops, then everything's gone, all your data's gone. And machines stop, they do, I promise. And so you're like, oh, but it's actually worse than that. Like, how do you know that you're never gonna make two? Because we actually have a thing at Wunderlist that does like this email thing. It like compacts events down, so you get like one email for like maybe 6 things that happened. But we can only ever run one. But believe me, we have ran 2 before. And it's very difficult. Yeah, so you're probably like, that's how I feel about that. Yeah, so how do you do it? How do you do it? That's the only way I know. You just let someone else do it. Zookeeper. Zookeeper is consistent. It's pretty available, and it's partition tolerant because of some paper that someone wrote that apparently is good. But the best part actually about Zookeeper, because it doesn't matter. Like Zookeeper is great, except that like I don't know how to use it, right? But they have recipes actually documented. Like they have a whole page in the docs they keep up to date. And then I got interested. I was like, okay, I can. It's like baking a cake. It's like I may not succeed, but I can follow the recipe, right? And they have a recipe for distributed logs, which that sounds interesting. So see, we're getting somewhere. I promise. Like, well, maybe. And I just wanted to reference DJ Khaled, because he's great. So he always says like that's a major key or whatever. And so distributed locks is the major key to getting where I want to be. Either way, Zookeeper is a battle-tested system, right? Battle-tested. Like Netflix uses it, although there are 2 Netflix repos for monitoring and like launching Zookeepers. So apparently like they run it, but they've built like all this tooling around it, which makes me think like maybe it's not that easy. If you want to cheat, just go to Heroku and like pay for Kafka, and then just don't use Kafka, just use the Zookeeper they gave you, because they give you the URL for it. And that's fantastic. And it's on EC2, so if your other stuff's on EC2, like you're in the same data center, and like that's how you could do it. Like if you want to run like on another like DigitalOcean or something, then you gotta figure out how to install it and stuff. So yeah. Either way, with Zookeeper, we can know if one thing has happened before another. That's really the gift that it gives us. It can know that. You can't know if you're the first when it happens, but you can look back and say, was I the first? So I know that's weird, but that's how it is. So I made a thing called Highlander. It has a URL at GitHub, like everything else. I named it that because it enforces that there can only be one, and some of you are laughing because that is a reference to a 90s television show. And the name actually took the longest, like not writing the library. It's like finding the perfect name. Yeah. The best part, I think, about this show is that somehow they got Queen to make the song for the beginning, which is like, how did that happen? Either way. That's Duncan MacLeod of the Clan MacLeod. So in my library, objects in quotes, right? They actually persist their state. That's something else I want, right? I want these things to like, if the machine was to crash, I want to be able to get them back. And so it just takes its gen server state and puts it on S3 every now and then. And when it boots inside of init, it just reads a file named after itself. That's all it does. But when you ask it for things, it just responds from memory. We don't have to actually ever go to S3 unless something changes, because it's the only one. We know that we have the most up-to-date information, and we're just going to assume that there are no other applications that use that bucket, but whatever. And this is a feature that I don't even know if I actually implemented this. I made this slide, but either way, I want this to be a thing if I didn't already do it. I may have a branch I didn't push. Either way, it should time out. That'd be great, because then the system would really just reflect like the actual people that are using it, and I think that'd be really cool. So it puts process registry in Zookeeper, and you can do that. I don't know if you know how, so I was going to show you some code now. Gen server has this thing called VIA. I don't know if you've ever used it. I found it like really confusing at first, but it does work. You can do stuff like this. Instead of the name of your process, you have to give a tuple, and it's like via, and then the registry, and then whatever information you want to hand your registry as an argument. And then you put the normal function that you want to run, or whatever you want to handle. And this is how you make a registry. You only have to do 4 things. You have to be able to send a message. You got to figure out where to send it. You got to be able to add and remove things, and that's it. It's actually really simple. So that's what happens inside the Highlander library. Zookeeper is just a simple key value store. So the key is going to be the object's ID, which is just the concatenation of user and their ID, right? Or whatever the name of the thing is and whatever the ID of the thing is. And then the value is just the name of the node. Because once you know what computer something's running on with Erlang, it's pretty easy then to talk to it. This is some, I copied this pretty much straight out of the Highlander stuff. So the where is part of it, it just goes to Zookeeper and gets the value of a node with that name. If it doesn't exist, then obviously it just returns. I don't remember what you return, but there's a thing, a special, I think it's like colon error or something, you know, that you return when you don't find something. When you want to register a new one, we just create a new node. And then this is where the distributed lock thing comes in. So it's better to actually make a process to kind of be the node, like to encapsulate the idea of a node. So we do that. We start link a node. Znode, I made Znode, like it'll be on the next slide. And then you just look and see if you were first. Like I said, you can't know if you're first like when you start, but you can look back. And so if you were the first one, then that means that you're allowed to boot. If you weren't the first one, then you should not, right? And I return apparently already exists. And then this is the magic. With Zookeeper, you can create a key value. Like I think they call it a node. I think that's why I called it that. I generate a UUID just because that's what they recommend with this recipe. But I put the UUID like after the object name. It's just a way to make them more unique. I don't remember why. It's some race condition that takes care of. Yeah. And then the value, like I said, is just the name of where I'm at right now in node.self. You do make path true because I think I have some slashes in there, and they consider slashes like a nested path in their keys. But the real magic is this, is the fact that it's ephemeral and it's sequential. And sequential is the key word, right? Zookeeper will enforce that anything created in this key area, like this path, is in order, right? So it will actually append on the end of the name, the UUID, and then a number, right? That's what it does. And it'll be like 1, 2, 3, or 4. And it enforces that, and it makes sure that it's consistent throughout its little cluster. So that's how come you can then go look and see if you're the first one in that path, right? And ephemeral just means that if we drop the Zookeeper connection, all the keys that we have created will be deleted immediately. Because if we drop our Zookeeper connection, then there must be something wrong with our server, and so there's no reason that those processes won't be running at that point. So Zookeeper keeps time in order, but it's important that we help OTP out so it can keep our processes running. I like this rest for one strategy, because what this means is if anything happens with Zookeeper, then it kills everything after it. And then starts over at the top, right? So it's like, or if something happens with the server, it kills everything after that, it goes back and it starts at the top. And so that way, like I said, if our connection drops with Zookeeper, then every single object that I've created, object in quotes, will get terminated, and you just wouldn't find it after that. So it's great. But I care about the developer experience. So I provide some macros in my library. And this is an example from my test file. To create a task or to do, you give that type, and that's like the first part of that tuple, and then it just assumes there will be an ID. And then I implemented a def object macro because I thought that was funny. And it just does def struct for you. So if you don't do the def object, then it just returns a map every time as like the thing that it's going to serialize and deserialize from S3. But if you do def object, it just takes that map and puts it in a struct for you. This is how you use it. You can get stuff. If you right now, for some reason, I decided that if you get an ID that doesn't exist, I return an empty object instead of returning nil. And I don't remember why I did that. It's probably not a good idea. Either way, that's what it would look like. And then you can update things. And it will, when you do the update, it will serialize S3. And then later, or on another machine, or whatever, you can just get it and it'll be there. Yeah. So at that point, you can start just creating everything. Users. And what my biggest thing was, though, if every user has a database, but like if we share like a document or something, like how do we model that? Because do you own the document? Do I own it? I say just make it its own object. So in Wunderlist, like you can share a list. So this is kind of what we would do then. We would create a list object that might have some to-dos in it. And then we just have to set up some permissions around that. But then each list would be like a collaborative object in the system that you can talk to directly using message passing. And it'll keep its state, serialized and all that stuff. Yeah, I don't know why I'd repeat myself. Good. If you want to do permissions, this is an idea I had, which is like the user can just have some list they've heard of, and then the list can actually do the enforcement of who's allowed. I'm still working on like what updates look like. I was thinking about doing this like handle update. At first I was going to do like agents where you do like get and update and you pass a function, but I figured like maybe it's better to have like a handler. And I think I actually forgot the state argument at the end there, but yeah. But you get some sort of thing, modify the state, return it just like a gen server. Yeah, and then it would handle putting it on S3 and everything right after that. A good thing about this for scalability purposes is like if one list or document or whatever was like super active, like it wouldn't slow anyone else down. It only slows down the people that are involved in that activity. And that would be great because, if you have this monolithic database, like everything I've ever worked on, when that thing slows down, it affects every customer, and it's super annoying. Just a quick aside, to write the tests, I had to boot multiple Erlang VMs, and that's really interesting. It turns out Phoenix does this for the pub sub stuff, so I just copied what they do. And it's just some really gnarly Erlang type stuff, yeah. I don't know, I thought that was interesting. Either way, there's a file inside of Highlander support cluster, and it has all that stuff. But you have to boot this thing, and I don't know what this does, so someone needs to tell me. But if I don't boot that, it doesn't work. And that's how I feel about that. So, yeah, but it's like scaling, right? So this comes back to what Joe said. That's the reason I mentioned it. If you really did model everything as a process, it would be like pouring sand into your cluster, right? You would get scaling in quotes. So you're probably thinking, how many locks can a small? I don't know. I have no idea. You could shard Zookeeper, or you could do what other people do. I'm not the first person to think of this idea. Most people would actually just use Zookeeper to set up shards and then put processes based on their ID on the machine that's designated for like all the ones that begin with 0 go here and all that stuff. That's what Halo does, actually, believe it or not. For multiplayer, they create an object for every game, object for every person, and they collaborate using message passing. If you don't know what Halo is, it's a game. They use this thing called Orleans, which is a .NET or a C# or something actor framework. I think it's modeled after Erlang a little bit. And but it does basically what I told you, which it keeps its state kind of on disk and makes sure there's only one, and they do a Zookeeper sharded thingy. And that's a URL you'll never remember about where it is. There's another thing at Microsoft called Service Fabric, which I'm always really excited about, but I can never find a use for. But it lets you create stateful actors, stateful services, and know that something happens in one place. And they do the same thing. They use Zookeeper actually to set up partitions, and then they partition stuff based on that Zookeeper registry. So I think that's really interesting, and I would love to have a really good production library to do this. You're probably thinking like, what about Akka? You said use that's fine, yeah, it'd be great. I don't know, I don't really want to do any more Scala, but Akka's a great library. There's this thing called React Core, and I think that's great. I just don't trust myself to implement all the Zookeeper stuff. I don't even know if the way I use Zookeeper is correct. You know what I mean? Like just because they have this recipe doesn't mean I baked the cake correctly. So that's how I feel about that. So this is the point. I think you should have fun. I think you should have crazy ideas. You should build stuff, and then you should, or you should apply for a talk for something you wish you would make. And then when it gets accepted, then you'll stress about it. Okay, that's pretty much it. Like I said, I was going to finish pretty quickly. I can go back to any of that code stuff. I would like for you to ask questions, no matter what. I just don't want you to make a long statement that's not a question. That's all. That's all I ask. It's good time.
All right. The way we're going to do this is, if you're in a hard-to-reach place, please pass the microphone down the row. I saw a hand back here. Awesome.
Hiya. Great talk. Cheers. So, sort of maybe a double question. Are the S3 documents immutable themselves? Were they append only with events that had happened?
It's just a JSON document.
Just JSON document. So okay, change that.
But it would be great to do something like event sourcing, right? That would make it really cool, I think.
Okay.
Yeah.
So the second part was, do you keep any sort of logical timestamping for how far each actor has stepped through?
I started on that. I haven't pushed it yet. But we do that at Wunderlist. We keep a clock on every object, and I would do the same thing. I would just put a number and increment it. Yeah. I think that'd be useful for a lot of reasons. Yeah. Oh, something I forgot to mention is you're probably thinking how do you do a query across a database like this? But you could actually just have a trigger on any change in the S3 bucket, go to SNS, and you could just put that in Redshift. And then you would actually have a monolithic database that's mostly up to date of all the data in the system. And you could do your queries there for like analytics purposes and stuff. I should have made a slide for that. I made so many slides. It was 155, just in case you're wondering.
Have you run into any performance issues with S3 along rate limiting because they support like something along the lines of 100 requests per second on gets?
I have not. But if that happened, I would just be upset. Yeah. Yeah. I mean, you could use Postgres as the store, you know what I mean? And you wouldn't be hitting it for gets other than that initial load. So it would reduce your queries per second by a huge percentage. So I think that would actually be a very good strategy as well.
What was the problem with global library?
Sorry, can you repeat that?
What was the problem with global library?
Global allows, when there's a network partition, you might end up with two processes with the same name.
But it tries an error when you try to raise a...
Well, during a network partition, you don't know that that process already exists. That's the problem. That's what I mean.
Okay.
And so the Zookeeper does like like this crazy Paxos thing to try to ride out a network partition and make decisions correctly, right? Which is apparently the hardest thing, computer science or something. I don't know. Yeah.
Thanks.
Seriously, I mean, it must be hard. Yeah, I mean, it's normal. Like most applications don't handle network partitions well. It's just normal.
No more questions? All right, give it up one more time.